So let's start off with, what is a heat pump? So heat pumps use the same underlying technology as refrigerators or air conditioners. At their most basic, they absorb heat, concentrate it, and move it. They're fully reversible, providing both heating and cooling, which is pretty neat. And heat pumps use electricity highly efficiently. They provide 2 to 5.4 kilowatt hours of heat for every kilowatt hour that they consume. For comparison, gas boilers and furnaces in Canada are typically rated at 82 to 98% efficient, while electric boilers and baseboards are up to about 100% efficient. Next slide, please. So why heat pumps? Simply put, they're an excellent climate solution. According to the International Energy Agency, electrifying heating with heat pumps can reduce global greenhouse gas emissions by more than 500 million tons in 2030. In Canada specifically, buildings are the third largest source of greenhouse gas emissions. Space and water heating specifically contribute the majority of those building emissions. But in major cities, buildings can actually make up a much larger percentage of emissions. For example, in 2021, buildings were 61% of Toronto's emissions. As over 80% of electricity generated in Canada is from low carbon sources, electrifying buildings can enable Canada to achieve its climate targets. So let's jump over to the myths. So myth one is heat pumps are a new and untested technology. Heat pumps are actually an incredibly old technology, having been invented in 1856, and heat pumps have been in Canada since at least 1948. However, early heat pumps in Canada were very simple single-stage ones that were better suited for more temperate climates rather than the cold winters that many places in Canada have. Unfortunately, it gave heat pumps a bit of a bad reputation in Canada with many Canadians. So what makes modern heat pumps different is their ability to maintain capacity, and they can heat during very cold outdoor temperatures. And that is due to major efficiency improvements, advancements in inverter technology, and the addition of variable speed motors, which results in highly effective cold climate models. So heat pumps are also back to the first slide, please. Thanks. So heat pumps are very popular in many countries that are as cold or colder than Canada too, which is pretty neat. For example, Estonia, Norway, Finland are all colder than Canada are by a population weighted heating degree days, but they have heat pump penetration rates of 3 to 6 times higher per capita than Canada. In Norway, for example, 60% of buildings have a heat pump, which is pretty cool. So heat pumps' popularity has also been growing in Canada, particularly in the Maritimes. As of the latest census, they're the most common primary home heating system in both New Brunswick and Prince Edward Island, and they're a close second to furnaces in Nova Scotia. But I bet in the next census, they'll probably even overtake them since they're becoming so popular. So let's jump over to myth two. So myth two is Canada would be alone if requirements for cleaner and more efficient heating were introduced. So several jurisdictions in Europe actually have already introduced or announced bans on fossil fuel heating equipment. For example, Austria, France, Ireland, the Netherlands, and Norway all have bans on oil and gas boiler installations in new buildings that started January 1st. In the US, the New York State legislature has recently approved a state budget prohibiting natural gas and other fossil fuel heating and cooking equipment in new buildings that are shorter than 7 stories by 2026 or by 2029 for taller buildings. So this type of policy has been gaining traction due to the very high upfront cost of adding new developments to the natural gas distribution system, as well as the additional risk of stranded assets when you have to eventually electrify. So closer to home, still in myth two, Closer to home, Energy Star, which is the most widely used energy efficiency label in the United States and Canada, has proposed sunsetting Energy Star certification for residential furnaces and central air conditioners, effective December 30th, 2024, which signals a potential path for future regulations, since the current minimum standard for most furnaces in Canada, which is 95% rated efficiency, was previously the Energy Star minimum, which is pretty cool. So on to myth three, is that Canada is too cold for heat pumps. So there's a lot of great new technologies that make this false. So in 2021, Natural Resources Canada, in partnership with the US Department of Energy, launched a program called the Residential Cold Climate Heat Pump Challenge. So it's been really neat since a lot of different HVAC companies that are manufacturing heat pumps have been competing to make better and better technologies. So it's been very successful with both Trane and Rheem, 2 different heat pump manufacturers, developing new heat pumps that have been performing down to negative 31 degrees Celsius, which is very cold. But I think it's also really important to mention here that a large share of heat pumps on the market already have built-in electric resistance heating that kicks in when temperatures drop too low for the heat pump to work alone, and still maintains 100% efficiency. So it's not that at -31 that you suddenly have no heat. There's the backup technology that kicks in to help out. The government of Yukon also performed a pilot project on cold climate air source heat pumps retrofitted to 5 homes in Whitehorse. And so even at -28.9 degrees Celsius, the best performing heat pumps there maintained greater than 100% efficiency, meaning that they were still more efficient than any of the alternative heating technologies, even at that cold a temperature. So when I say the best performing heat pump, please know it's not cherry picked. Unfortunately, in that pilot, some of the homeowners were allowed to pick their own size of their heat pump. And since a lot of people are used to picking fossil fuel equipment a little bit oversized, which is something you don't want to do with heat pumps, unfortunately, it lowered the efficiency of some of the oversized equipment. So on to myth 4, which is using a heat pump costs more than a fossil fuel-based heating system. And so although the upfront costs of a heat pump are higher than the cost of a furnace, it's important to remember that heat pumps can replace both heating and cooling equipment for a building, and that there's federal, provincial, and municipal incentive programs available that help lower the upfront costs. In terms of the utility costs, a 2022 NRCan study found that homeowners switching from an oil furnace to a cold climate air source heat pump could expect to save $1,000 to $3,500 annually in utility costs, which is massive. Similarly, switching from an electric resistance heating system to a cold climate air source heat pump generated $700 to $1,900 in savings. And they also did find cost savings from natural gas systems in most regions. A large portion of that was the fixed natural gas charges that can range from about $150 to $300 a year in Canada. So being able to disconnect from the gas system with the cold climate air source heat pump eliminated those costs, which were pretty neat. It's also important to keep in mind with that study that they used August 2020 prices, and natural gas and oil prices have both increased since then. So the cost savings should be even better if they were recalculated today. And also with the federal carbon tax increasing annually by $15 per ton up to $170 per ton in 2030, the relative savings from a heat pump will continue to grow. Electricity prices are also far less volatile than fossil fuel prices due to their lesser interaction with international markets and the greater regulation. So, for example, according to StatsCan, fuel oil and other fuel prices were up 73.4% in November 2022 compared to the same month in the prior year, and natural gas was up more than 23.7%, whereas electricity prices were only increased 1.6% averaged across Canada in the same period. So far less volatile. So it's much easier to anticipate what your utility bills would be if you install electric-based systems like heat pumps. So for myth 5, electric grids don't have the capacity for heat pumps. So in a lot of the discussions around heat pumps, there's an assumption that almost everybody would be switching from a fossil fuel system, therefore increasing their electricity consumption and peak demand. But in reality, according to the latest census, 40% of Canadian households' primary heating systems were actually less efficient non-heat pump electric systems like baseboards or electric boilers. So adding a heat pump to those homes could decrease their electricity consumption by about 1/2 to 2/3 on average, which is pretty enormous. And as you saw in myth 4, would reduce their utility costs as well. So additionally, even if every household did switch from a heat pump when their fossil fuel heating equipment reached end of life, given that furnaces and boilers generally last 15 to 20 years, that's only about 5 to 7% per year. So electrification would happen very gradually over time. This gives electricity system planners the ability to plan ahead and to respond. Energy efficiency programs are also a really great way to lower the cost of electrification. For example, a study by Power Advisory for the Atmospheric Fund modeled Ontario's electricity grid reaching net zero by 2035. And they calculated that investing in electricity conservation and demand management to reduce expected demand by just 11% could reduce the need for additional wind, solar, and storage capacity by almost half. So definitely shouldn't forget about energy efficiency when we're talking about bringing on heat pumps. And while the majority of the Mythbuster, just because they're more popular in Canada, is about air source heat pumps, we definitely shouldn't forget about ground source heat pumps, which can also be a really great peak demand solution, as underground temperatures are warmer and more stable than air temperatures in the winter. they can operate more efficiently than other types of heat pumps at lower temperatures. So in a report for HRAI, Density, Energy, and Climate Advisors calculated that the upfront cost of ground source heat pumps, even though they are higher, is more than offset by the peak load and electricity consumption benefits they provide. So they can also be a great solution in many cases to lowering the peak demand issues that are often discussed with heat pumps. So myth 6. In provinces with dirty grids, heat pumps don't lower emissions. So according to the IEA, heat pumps still reduce life cycle greenhouse gas emissions by at least 20% compared to a gas boiler, even when running on emissions-intensive electricity. And there was also another study in Nature in 2020 that similarly concluded that the average heat pump would have a lower life cycle emissions than an average new gas boiler, as long as the electricity grid's emission intensity was less than 1,000 grams of CO2 per kilowatt hour, which is actually significantly lower than any province or territory in Canada. For comparison, Saskatchewan, which currently has the highest emissions intensity of any province in Canada, has 730 grams per CO2 per kilowatt hour. So only about 3/4 of the number that's in Nature. The emissions intensity of electricity generated in Canada has also actually fallen 45% between 2005 and 2019. And with the federal government targeting net zero emissions electricity by 2035, the emission savings achieved by a heat pump will continue to grow as the grid becomes increasingly clean. In provinces that still have slightly dirty grids, adding on-site renewables like rooftop solar can also reduce emissions and costs while the grid is decarbonizing, or hybrid systems that use a heat pump paired with natural gas or other systems can also be a solution for during peak heating, when the grid is using the dirtiest sources of electricity. And so heating systems are only replaced approximately every 15 to 20 years. So it's really important to not wait to install a heat pump, because a fossil fuel-based system that's installed now will still be a significant source of direct emissions until about 2040, which is a very long time to wait to be able to decarbonize your home or business. So on to myth 7, which is heat pumps are not climate friendly because they're refrigerants. So it is true that most heat pumps in Canada use HFC-based refrigerants, which are a potent source of emissions. For example, our 410A, the most popular heat pump refrigerant, has a global warming potential that is about 2,000 times more than that of CO2. But despite this, according to the IEA, a heat pump using current refrigerants would still reduce emissions 20 to 80% compared to a gas boiler, as refrigerant leakage rates are really low with good installation and maintenance practices, and compared to the guaranteed emissions from the combustion of fossil fuels. There are also really interesting new low global warming potential natural refrigerants like CO2 and ammonia that are gaining in popularity. It's definitely counterintuitive when talking about the climate to think of CO2 as a good thing, but as a refrigerant, it's very green, since its global warming potential is only 1, as it's the benchmark for other refrigerants. Additionally, air conditioners use many of the same refrigerants as heat pumps, so it shouldn't really be used as a knock against heat pumps, since if you're using a heat pump and it's replacing an air conditioner as well as displacing fossil fuel from the heating system, the amount of refrigerant being used in the building would likely stay the same or increase only slightly, depending on the size of the heat pump, while reducing the combustion emissions substantially through electrification and the heat pump's increased efficiency. So on to myth 8, a gas furnace can still heat if there's an electrical power outage. So in the event of a power outage, there's this idea that a heat pump wouldn't work while a gas furnace would, which might make some people want to stick with fossil fuels. However, a furnace fueled by gas is also dependent on electrical fans that push the waste products from the combustion process out the flue. So without this, occupants could actually experience carbon monoxide poisoning, which is very serious. Therefore, the furnace's built-in safety system doesn't allow for it to run during a power outage either. The only home heating system that doesn't require some sort of electricity is a heating stove, which is only the primary home heating system in about 2% of Canadian homes. So instead, we should think about high-performing building envelopes, which are an essential resiliency measure, as indoor temperatures would drop far more slowly in the winter, which increases the amount of time occupants have safe temperatures. For example, homes that are built with building envelopes that are up to the Passive House standard are able to maintain safe indoor temperatures for over 6 days during a winter power outage, which is pretty amazing. Smart home electrification can also be a really important resiliency measure. For example, using electric vehicle car batteries that can power your home system as well in the winter. And so onto myth 9, which is heat pumps will not work in older homes without extensive upgrades. So a very large percentage of HVAC installations in Canada are emergency replacements. Unfortunately, so it's very common to not have time to do a deep retrofit before switching to a heat pump. So a heat pump can still provide very efficient and low carbon heat and avoid locking into a new high emitting heating system for the next 15 to 20 years. Heat pumps do work in older homes and can be chosen over standalone fossil fuel systems, even with minimal existing insulation and air sealing. But it's important to have plans for future envelope upgrades considered when choosing a heat pump. HOT 2000 and other energy modeling tools can be used to size a heat pump appropriately to meet 100% of the heating needs for the future home, with electric resistance supplementing in the meantime. So you can make a plan for like your future home to look like with the insulation and air sealing upgrades. And this is really important to avoid oversizing the heat pump. As mentioned previously, oversizing can lead to short cycling, where the heat pump comes on and off too frequently, which rather than operating consistently, which is quite inefficient. So the Toronto and Region Conservation Authority Sustainable Technologies Evaluation Program has really excellent case studies of older homes being retrofitted with heat pumps, one of which was referenced in our report. And so I definitely recommend you check those out. On to the last myth, myth 10, HVAC contractors do not support heat pumps. So when talking to friends and family about heat pumps, I've definitely heard more than a few times that someone asked a contractor or technician about a heat pump and were told that they don't work or were discouraged from getting one. But the tides are definitely turning as technology has vastly improved and more people in the industry are becoming more familiar with heat pumps. For example, HRAI, a trade association that represents Canada's HVAC industry, recently published a report recognizing that HVAC are representing refrigeration contractors need to play a leading role for Canada to meet its international carbon emissions reductions obligations regarding building generated emissions. The report finds a broadly held desire and a willingness among HVAC contractors and business owners to do more to mitigate climate impacts through solutions such as whole home retrofits and heat pumps. Additionally, many well-known heat pump manufacturers have lists of qualified contractors that install and service their products, which you can find on their website, which can be really helpful if you are looking for a heat pump for your home. Next slide, please. Thanks. So those are all of the myths. You can download a copy of the full report from our website for more details and for all of the references. And now that you know that heat pumps work in Canada, I'll pass it over to Alexander, who will talk about how to actually get them in people's homes, especially when these myths are still prevalent. Thank you.
Thank you so much, Sarah. Allison, do you want to say something first?
I did. So I'm just seeing a lot of questions in the chat right now about the different references that you were talking about, Sarah. So some of the HRAI reports. And before we move on, I'm assuming those are in the report. So I think if you're looking for the references to what Sarah was mentioning, you can actually go into the report and they should be there. Just to help people out, would you be able to maybe put some of those links in the chat?
Yeah, absolutely.
Okay, that would be fantastic. So I'm going to task Sarah with that in the background while you get going, Alex. So I will just make you co-host and then you should be able to share your screen and just get going.
Excellent. All right. Here we go. Can people see that? Is that working?
Yeah, looks awesome.
Right. And about how much time do you think it makes sense here? Because I want to make sure I leave enough time for questions. So thank you, everybody. As Allison mentioned, my name is Alexander Gard-Murray. I'm director of the Greenhouse Institute, and this is work co-authored with Brendan Haley, Sarah Miller, and Matthew Poirier. And I'm not going to spend a lot of time here talking about the advantages of heat pumps, because I think Sarah's done a terrific job already going through those. Instead, I'm going to talk about one specific opportunity, one specific way to get more heat pumps into Canadian homes. There's other ways, there's other important things we need to do, but this, I think there's a real chance. And it takes advantage of something that Sarah mentioned, which is that heat pumps can cool as well as heat. Despite the word heat in the name, they're essentially air conditioners that can run in two directions. That's the basic functioning of a heat pump. Before I get into the details, I'll just mention we got a lot of partners working on this project. This is a collaborative effort, and here are some of them here. So Canada is, always been a nation that required a lot of heating, but it's increasingly becoming a cooling nation as well. In lots of provinces, the number of central air conditioners, ones that push air through ducts in the house, have doubled or even quadrupled or more in provinces over the last 20 years. People are increasingly demanding cooling, and in part that's because of climate change, right? Climate change is driving more demand for cooling. The problem there, while cooling is needed from a resilience perspective, is that cooling also just adds demand to the grid. So it's a net negative for emissions, even though it's needed to deal with warming. Heat pumps present an opportunity to turn this extra demand for cooling into a benefit for the climate and also benefit for people's pocketbooks. Here, to summarize, heat pumps are better than air conditioners. And that's because, as I said, heat pumps can do all the things that the air conditioners can do, but can also heat. And in the rest of this talk, I'm going to be focusing in particular, again, on that ducted kind of system, the system that pushes air through the ducts in the home, so not like a window air conditioner. The sales of ducted air conditioners in Canada way outpace the sales of ducted heat pumps. So 7,000 new ducted air conditioners are installed each week, about 360,000 a year. And the number of heat pumps installed each year is just about a tenth of that. So there's this real gap. People are installing air conditioners, even though they could be installing heat pumps. And what makes this missed opportunity is that not only are these machines pretty similar, but they're actually pretty close in cost to produce. Having built a central air conditioner, it's only a few extra $100 in parts to make it into a heat pump instead. It's basically just equipment to make the air conditioner switch directions, a reversing valve, a few other parts, at least for a kind of basic minimum model. There are sort of fancier models, which are more expensive for heat pumps, kind of what are called cold climate heat pumps. But a basic model heat pump that can do some of a home's heating just costs a few $100s to make, and only about $500, $600, $700 more for a consumer to buy. So it's not just that the machines are similar, but it's that they're similar in cost. And so if we could get people, if we could make all the air conditioners, all the ducted air conditioners sold in Canada into heat pumps instead, we could really revolutionize the number of heat pumps in Canadian homes really quickly. The only question is, why aren't heat pumps selling already? And there's a few barriers. I'm not going to kind of spend a lot of time here because I think Sarah's covered these already. People aren't so familiar with them. It's something that people only buy occasionally. You have a really short window to replace them because usually an air conditioning system or a furnace, once they fail, when they're being used heavily. So people want to replace them immediately. So it depends on what's in stock and what contractors are familiar with. And because heat pumps don't currently represent a large part of the market, there's often limited stock availability. So even if you want one, you might not be able to get one on the timeline you want. And as I was saying, they might only cost, say, $700 more at the base model than a comparable air conditioner, but still that upfront cost difference can turn people off. The solution we propose is to phase out sales of all ducted air conditioners and make ducted heat pumps the default. They'll still do everything that ducted air conditioners do, but they'll also take on some of the heat load. And that's going to have important benefits all across the market. So manufacturers all make both air conditioners and heat pumps. So they're ready to switch as long as they know demand is there. Distributors get to carry fewer kinds of products, which lowers their inventory costs. And for contractors, unlike existing programs that involve some kind of complicated bureaucracy to navigate, this happens upstream. So it just changes what they need to install, but they don't need to worry about sort of more complicated sales transactions. And consumers, as we're going to talk about, save money and reduce their own greenhouse gas emissions. And it's especially helpful for renters whose landlords might install a central air conditioner. Now they'll automatically get a heat pump instead. And I just want to briefly note that this has already been tried in Canada. Vancouver has implemented this policy, and they've had a really positive experience with it. They've called this transition smooth. Most people who are installing heat pumps are installing above the minimum there. And as Chris Higgins, who works there, a senior green building planner, says it's one of the easiest things a regulator can do to rapidly improve the market for heat pumps. So their experience has been really positive. So we did some modeling. I'm not going to go through all the details because of time, but basically we're being conservative. We're not assuming that people get the fanciest heat pump that can heat their entire home, even down to the coldest times. We're assuming someone just gets a minimum, someone described it the other day as the Honda Civic of heat pumps, and that they keep their existing fossil fuel or electric resistance backup for the coldest days. Now, again, you can get a fancier heat pump that will do all the home's heating load, but we're not assuming that. We're assuming a really conservative system that people get. And the benefits across Canada are pretty big. So we look at bill reductions. People are saving between $100 and, if you're moving from pretty expensive electric resistance, more than $1,000 a month, or sorry, a year in some provinces. So we're talking about really substantial bill savings, or in some cases, if you're moving from an efficient gas system, little bill savings, but ones that are enough over time to pay back the additional cost of the heat pump. There's also big greenhouse gas reduction benefits. And again, this is assuming that you're still using the existing fossil fuel or electric resistance system. We still see big greenhouse gas reductions because heat pumps are just so efficient, because they're not creating heat, they're just moving heat around. The outcomes for Canadians, when we aggregate these benefits across provinces over a 10-year period, there's additional costs to buy them. That's the upfront cost, $700 per heat pump. Some of that would actually go away because the government has incentives to buy heat pumps. We're not factoring those existing incentives in at all. But there would be some additional capital costs, but those are way outweighed by the benefits. So we'd see 5.4 million additional heat pumps installed, causing $10.4 billion of energy bill reductions, almost 20 million tons of emissions reductions, which comes out to about $6 billion of climate benefits when you use the government's method for monetizing those. There's a few different ways we can implement this. I'm not going to talk about all of them. I'll just say the simplest way is the government could say, you have to, right? That an air conditioner has to be able to heat. A ducted central air conditioner has to be able to heat. That's what Vancouver has done, and they've seen great results. There's also ways to do it through building codes, possibly offering incentives to manufacturers or distributors, but the simplest way would just be to require it. And again, I think most market participants are ready for that. I'll just close by saying that this is a really important step for long-term electrification. What we're proposing would not get every house to net zero. It would not displace all the existing fossil fuel heating, but it would make sure that many more families get used to heat pumps. It makes sure that contractors become familiar with heat pumps. It makes sure that we avoid locking in 300,000 or more air conditioners a year, air conditioners that will last for 20 years and thus make it harder for people to buy a heat pump. So the earlier we do this, the better. This is something we're promoting in government, and I hope this is something that people might get excited about. Happy to answer questions, and thank you for your time.
Fantastic. Thanks so much, Sarah and Alexander. So would you mind just unsharing your screen, and we'll go back to the people. Thanks. Sarah, did you want to come back online? Fantastic. Okay, we've got quite a few questions in the inbox right now. I would just encourage you, if you are asking questions in the chat, if you could move them into the Q&A boxes, just copy and paste them right in there, because that's where I'm going to be drawing most of the questions from. So we've got quite a few, and I think we'll just start from the top here. So Sarah, most of these questions are going to be for you, and just were sort of asked throughout the presentation. So we'll start with Stephen's questions. So for commercial buildings with complex HVAC systems, if they go to a heat pump system, would they be replacing both air conditioners and boilers?
That's a great question. Oh, sorry, the question disappeared. Is it possible to keep it there? Just to refer to.
I will not do it again, but
okay.
I don't know where I put it.
Sorry. So for commercial buildings, it's not my area of expertise, but I think some of them can be more complex. So I think they're much more context specific than residential. So I would have to ask one of my colleagues that is more in tune with commercial buildings and get back to Stephen for that.
Okay, great, thanks. So for a residential home, would you still need a furnace on top of a heat pump for really cold days?
Yeah, that's a great question. So as I mentioned, with cold climate heat pumps, most of them have a built-in electric resistance heating already in it. So it just to explain it really basically, it's basically like a little the same technology as like a toaster oven. It's heating coils in the back that provide all of the backup resistance, all of the backup heating you can need down to any temperature. So you can completely replace a gas furnace system.
Fantastic, thanks. Alex, if you want to jump in on any of these questions, go for it.
I'll just jump in to note, yeah, you can get a cold climate system that does totally replace the existing heating, like Sarah just said, or you can get what we call kind of a hybrid system, one that sits alongside your existing furnace and combine them. So it's up to you.
Fantastic, thanks. Okay, so this question is about embodied emissions. So the discussion on refrigerants, is it currently considering embodied emissions?
That's a great question. I just put a little follow-up question there. Is the question being asked about the embodied emissions of producing the refrigerants or of the equipment?
Did you maybe want to address both? One or the other?
Yeah, in terms of the embodied emissions of the equipment, Alex, please step in with this, but I think the embodied emissions of air conditioners and heat pumps is relatively similar, whereas with the refrigerants, I haven't seen any studies about the embodied emissions of refrigerants, but that could definitely be very interesting.
Yeah, for the AC to heat pump swap, you're basically all the embodied emissions of like the metal and everything and the refrigerants, all of that you were going to do for the air conditioner anyway, except now you're getting all this heating value out of it as well. So that's definitely a win in terms of embodied emissions.
Fantastic. Thanks, both of you. So this question, I can pose this to both of you as well. And it wasn't necessarily the scope of the research so far, Sarah, but we'll ask it. And I think we can also recommend some articles too, if we're not able to answer it. But we have a question about the electricity grids and their capacity. So this individual is hearing a lot of concern from the building sector that the electricity grids may not be able to meet the increased demand for heat pumps and EV charging infrastructure, which is where we're going. So just wondering if you had any comments on that.
Yeah, I would definitely refer them to the Canadian Climate Institute, a great study called The Big Switch, where they tackle all of those questions. So any of the references in the Heat Pump Mythbuster about that are pulling from that report. So I definitely refer them there.
And just in general, since some of these systems are going to be hybrid systems, the using a fossil fuel system on just the few coldest days really mitigates a lot of that worry about peak demand. Also, the fact is, as Sarah mentioned, just to reiterate, if you're replacing an electric resistance system, that already puts pressure on the grid, a huge amount of pressure because it's way less efficient. So you're lowering peak demand when you're getting a heat pump and replacing electric resistance. So I think this is probably going to be better for the grid.
Thank you. Okay, so this one's about building size. So is there a rule of thumb where heat pumps would not be a good solution?
Yeah, not as far as I know, since you can have multiple heat pumps in a building. So I haven't heard any rules of thumb there, since you can have, I guess, as many as the building needs. And even with the ductless ones, you can have multiple zones and multiple heads.
Yeah, there's big institutions, right, which have large heat pumps, which heat whole facilities with air source or ground source heat pumps. So yeah, it's just you get more.
Okay, thank you. So this question, I think we're hearing a lot of, just even in some of the things we are focusing on as an organization at Efficiency Canada. So, and I think this applies to not only commercial buildings, but also residential as well, or multi-unit residential buildings. But in terms of sort of like the order, is heat pump, should it be the first thing? Should it be building envelope? Yeah, I'm just curious to hear both of your thoughts on this because we've had a couple questions in the chat about this.
Yeah, I think if you have lots of time to plan it out and to do a great plan, I definitely think building envelope improvements are a great place to start. More insulation, air sealing, they no matter what system you have, if you still have your furnace or if you switch to a heat pump, they'll give you energy savings, cost savings. They're great low-cost measures to decrease your energy costs, regardless of what system you have. I think more the discussion about the heat pumps in older homes was more if your furnace dies tomorrow and it's winter, you don't have time to wait, you can put a heat pump in without having to do those things first, since there are energy models available that to still right size your equipment, taking into account the kind of things that you have planned in the future. But it definitely, energy efficiency is a win no matter what system you have.
Yeah, I think that covered it, right? They're complementary. They're not in conflict.
And so we did have a question about oversizing, that there's no worry about oversizing the system if you choose to do the energy efficiency measure second.
So there definitely is a worry about oversizing, which is why you'd want to have the energy model first. There's Hot 2000 is really popular in Canada, or there's other energy modeling software that can take into account the things that you have planned, since if you do oversize, your heat pump can be cycling on and off a lot, so it can become inefficient.
Right, great answer. Thanks, Sarah. Okay, so this one is kind of, I think, the crux of some of the issue right now. So convincing city planners to adopt, I don't know what this stands for, maybe one of you do, ZCSC, faster in new builds. How are we doing in convincing city planners to adopt this stuff? I think there's some building codes elements too. What work is being done right now to help, to help people consider adoption of heat pumps, and especially city planners, even at the provincial and federal level? Do either of you want to provide a bit of an overview there? Sarah, maybe you can go first, because I know you're doing a bit of work on this.
So unfortunately, building codes aren't an area that I'm very well versed in, but it is a really great question. So our colleague Kevin is the guru for building codes. So I can definitely bring it to him, and we can get back to you, Laurie.
So I'll just add here, right, that as I said earlier, Vancouver has implemented this. So it's definitely possible to do an AC to heat pump switch through the city level, as long as the city has the appropriate regulatory powers, which I think differ from jurisdiction to jurisdiction. Also, something we discussed in our report is that the federal Minister of Natural Resources and the Minister of Science, Innovation, and Industry, they have a mandate to develop a model retrofit code that's triggered when alterations occur to existing buildings. So you could change that model retrofit code to require the installation of heat pumps instead of new central air conditioners. And I think that would be one way, by having that model code that cities could adopt, one way to help them do that.
Right. Yeah, that makes complete sense. So yeah, Laurie, I know you asked the question. Part of the work we're doing in the background too is on building performance standards. So I think that, if that passes, and it's passed in a few. So again, Vancouver has that. Toronto just published plans to have building performance standards that are even sort of broader sweeping than Vancouver. Oh, somebody just put the report in there. So I think, and Montreal is considering the same thing. So they're just sort of working on getting the utilities on board right now for the benchmarking component. That I think that's something that could potentially drive the adoption of heat pumps as well, if the government doesn't adopt some kind of regulation citing that, air conditioning must also be heating elements as well. So we've got quite a few resources on that on our website. There's a building code section. So if you are interested, if you're from a municipality, if you're interested in either sort of the building codes component or the building performance standards, we do have resources on that are developed for municipalities. So absolutely, I would invite you to go to our website and check that out, and also, speak to Kevin or Shireen, who are both available to answer questions. Okay, so moving on. So do either of you happen to know if any utility or energy board offering a heat pump subsidy which fully or fairly reflects the value delivered to the regional grid in optimization or basic avoided costs?
I think that's a great question. I haven't personally heard of anyone calculating the social cost or the social benefits of heat pumps, comparing it to what the incentives are. I don't know, Alexander, if you have any.
Yeah, I don't know if anyone's done the work to compare those two things. I know there are incentive programs. In some provinces, low-income people can receive them for free. So that should presumably cover the costs. But as for data on specific ones, I don't have that at the moment.
That's an interesting point, Ted. So we're just about to come out with I don't know if it's going to cover heat pumps, but it might be an interesting conversation to have with some of our scorecard folks. They might have a better sense of what programs are out there. And, if we can make recommendations to provincial policymakers or even municipal policymakers, I think that's worthy of a conversation for sure. Because I hear you. I think a lot of the costs that are covered are not actually including the labor, construction. So it can be a bit disconcerting when you go to get a heat pump. So, okay, let's go to Megan's question. So ductless systems are being implemented in homes without existing CAC and hydronic heating systems. Are there benefits to ducted or hydronic heat pump system over a ductless option? Sarah, do you want to take a stab at that one?
I think that might be more to the engineering side of things than I'm personally comfortable answering. I don't want to give anyone the wrong idea for like a renovation project, but I can definitely try and get in touch with the right people if you're interested. I don't know, Alexander, do you have any
Yeah, no, I mean,
opinions?
I'll agree with the general point, right? That like this is something to discuss with a contractor because it's really going to depend on the home. I'll just note that the reason our report focused on ducted systems is just because almost all ductless systems, like mini splits, are already heat pumps, not air conditioners. So the technological opportunity for switching is really prominent in ducted, where most of the ducted units are air conditioners. But ductless units like mini splits are also good choices for lots of people. And so we're not against those.
Okay, this is kind of a cool question. So we have somebody on the line that's doing a research paper about the adoption of heat pumps in Peru. And hopefully you can share that with your government there, either federal or the local government. So he's asking, based on your experience doing this research, and I'm assuming on both of the papers, what would be the most important topics that should be investigated? Let's just start with that one.
Sorry, I'm just having trouble with the question because I'm like, oh, we think we've done the most important topics. Here's our results. But happy to if they want to send an email, I'm happy to talk about future research directions because Greenhouse and I imagine Efficiency Canada are always looking for more to do. I think one key crucial thing we want to do is actually a study on Vancouver, on a place which has actually implemented this regulation, because I think it helps to show people not just that modeling shows these things will benefit, but showing actual case studies. And I know that a lot of Sarah's stuff is rooted in case studies, I believe, right, of actual homes. So I think doing more of that in more places is really valuable.
Yeah, I agree. I think we're seeing the same thing with deep retrofits. Sarah, did you want to add to that at all?
No, I was just going to say Alexander's answer was perfect.
Fantastic. Okay, so we are a bit over time, and because we had two presenters, we're just kind of rolling with it. So I'm going to do one more question in here. And I would invite you that if you didn't have your question answered, again, we can't advise on your home projects. So, that's just not our role. I would encourage you to get in touch with the contractor. If you go through HRAI's website, they have wonderful contractors on there, and they all are part of the HRAI membership. So we'll do one more question today. And then if you didn't get your question answered, please reach out to, like I said, either a contractor, or if it is something that Sarah or Alex can answer, please reach out to them. I think from what it sounds like, you guys would be happy to answer questions after this or connect people with the people who can answer their questions. So I'll sort of leave this last question with both of you. And Alex, I think you had a slide in your presentation that covered it pretty nicely. But if you had to have people walk away from this presentation remembering one thing, what would it be from either pieces of your work? Sarah, did you want to go first?
That is a great question. Just trying to think about it. I think probably that the majority of HVAC replacements are emergency replacements, and the longer planning window you have time to get the energy audit so that you can take advantage of incentives, you can get the modeling done to get it right sized. So really just doing the annual maintenance and other things that give you an idea of when your HVAC system is going to be failing and when you'll need a replacement, so you can start thinking ahead, researching the different models and really thinking about it. I think that's really valuable, because the more time you have time for the energy efficiency improvements first. If you want to do those, it just gives you a better idea of what you're working with.
That's a great answer. Thank you. And then Alex?
Heat pumps are better than air conditioners. Right?
As
Again,
per your
7,000
slide.
people. 7,000 people are installing air conditioners instead of heat pumps. They're going to last for 10, 15, 20 years, and they're going to get less functionality. They're going to miss out on bill savings. They're going to miss out on GHG reductions. Heat pumps are better than air conditioners. If you're buying a central air conditioner, get a heat pump. And if you're a government and your constituents are buying air conditioners, help them avoid getting locked in to less flexible equipment. because heat pumps are better than air conditioners. You get a bumper sticker.
Sorry, I didn't quite catch that. What was your main?
Heat pumps are better than air conditioners. My poor
Oh.
family have heard me saying that too many times.
Fantastic. Okay, so I just put the links to both of reports in the chat for everybody. Again, I think Sarah mentioned a bunch of resources in her report as well. So if you go into that, you kind of have to go through the blog, and then if you go to the blog, the report is in the blog. So there's a bit of steps to get to the report. But thank you both so much for coming today. We had so many questions in the background. We did not get to all of them. Thank you all for your wonderful questions and for coming. And we will see you next time. One thing to note before we leave, this will be posted on YouTube. So if you didn't quite catch something or you want to go back and see the presentations again, they will be on YouTube. And feel free to share with anybody that would be interested in it. So thank you again, Sarah and Alex. It was wonderful to have you here.
Thank you so much for having us.
Thank you.
All right. Take care, everybody. Happy Friday. Bye-bye.